I'm going back just a little bit before I start on this lesson here, just to make sure that some of this stuff is remembered by you so we can move forward. Here we had a group of kids. They were being asked to write a quadratic function in factored form to represent a parabola that opens downward and has zeros at 4, 0 and negative 1, 0. And what you'll remember is that a number of things. In factored form means that we're going to have the function be, let's see, so factored form, this is an important part of it right here, right? Factored form means that we're going to be writing it in the form of f of x equals a times, open parentheses, x minus r, and close parentheses, open parentheses, x minus r again. Okay? And so what we have to do is we have to think about a couple of different things. First of all, if it opens downwards, that means the parabola is going to be facing down. That means it's going to have a negative number in the A position. And this is the A position right here, where we have 1/2, and here we have a negative sign, which means negative 1. Here we have the A position here. So if it's opening downward, it has to have a negative number there. Secondly, we see that we want a 0 at positive 4 and a 0 at negative 1, means that when we subtract from x, we're going to subtract a positive 4 and we're going to subtract a negative 1, which means this is going to turn into a positive, right? Minus a negative 1. So just real quick, I'm going to put this function in so you can see that this function for sure meets all of the factors. So this is the function k of x equals negative x minus 4, x plus 1. And I'm going to not write it in function form. I'm going to write it as y equals negative x minus 4 and x plus 1. Okay, and as I put that together in there, you can see this function is graphed. And furthermore, you can see the zeros are at positive 4 and negative 1. And you can also see that it opens down. Again, if we switch this, right, let's try putting a number 2 in there. That's just going to make it taller, right? It's making it taller. If I put a 0.5 in there, watch what happens. Negative 0.5. And that seemed to make it shorter, right? The vertex is shorter now. So this number here is affecting the vertex we see. And if it's negative, that makes it open down. Watch, if I take away that negative sign, now it's opening up, right? Everything is going up when it's positive. But when it's negative, everything is opening down. Okay? Here are the key features right here. We have a vertex. We also have these zeros, 4, 0, and negative 1, 0, and they come from right here. If I were to change this number 4 to a 6, see what happens? My 0 is now 6. If I change this to, let's say, a negative 6, right? Oops, not negative x, negative 6. Now that negative 6 now means the 0's been flipped over here to negative 6. Okay? So that's the idea behind these. As we look here at what these kids have done, they've told us who's right and who's wrong. Maureen's right. She's got the negative sign right. She's got the 4 and the negative 1 right. Michael does not have a negative sign here. Tim does not have a negative sign here. Tom is right. Judy has a negative sign, but she put positive 4, and so she put x plus 4, which means this would be a negative 4. And she put x minus 1, which would make this a positive 1. Let's put Judy's in real quick and see what that looks like. So negative x, and then we're having x plus 4, x minus 1. So now we see here's plus 4. We wrote x plus 4, but the 0 is at negative 4. And now we have x minus 1, and the 0 is at positive 1. Okay, so this is something that, we're going to get to here in a little bit to understand why it is that these can tell us our zeros really easily. So we'll figure that all out in a bit, okay? So this was stuff, we answered these questions yesterday. I just kind of wanted to remind you about that, okay? So what is it that the sign of the variable a tells you about the graph? It tells you whether or not it's opening up or down, if it's positive or negative, right? And the variables R1 and R2 tell you what? Those are our zeros. Okay? Use the given information to write a quadratic function in factored form. So it says here the parabola opens upward, so that means we're going to have a positive number for A. The zeros are 2 and 4, which means we have to have x minus 2, x minus 4, right? So you might have a function, f of x equals negative 3, x minus 2, x minus 4. You can do the rest of these the same way. I'm not going to do them because we did them in class. Oh, we'll do this one real quick because it's kind of an interesting one. We have a 0 at the origin. So what would that have to look like? Well, let's just see if we can write that out here real quick, okay? So we would have, you know, if it's a function, then we're going to call it f of x, right? So we know that. We're going to have an equal sign, right? And then if it opens downward, we've got to have a negative sign in front of A. A can be any number, so I'll just put negative 1. And then we're going to go ahead and write x minus the first 0. Where's our first 0? At x equals 0, so we'll put x minus 0 and close that parentheses. And where's the second 0 going to be at? X minus 5. X minus 5. So you may be sitting there and saying, this looks stupid. Why would anybody bother to write out the x minus 0 other than just to put it into this form? And you're right. We should just call that x, right? And in fact, we can do negative 1 times x, and we just call it negative x times x minus 5. So you'd say, okay, f of x, right? This could be rewritten as equal to negative x, right, times x minus 5. And so now I'm hoping you're asking yourself the question. You say, well, wait a minute. Since in this form, you know, x minus 0, does this for sure have 2 zeros for sure? Well, let's plot this and see what this looks like. Negative x times x minus 5. So, sorry, let's try doing this. Okay, hold on, let me take my pen off. All right, here we go. So we're going to go with negative x, sorry. Shouldn't be messing around like this. Let's see if I can get my computer to catch up. Negative x times x minus 5. And you can see, sure enough, because nothing is being subtracted by this first x as it's factored, then that means it is just going to be going through 0, the origin. And in the second 5 that's being subtracted from x, we see that, sure enough, we have a 0 at 5. Okay? Now, what is the A? You can check it again. How does the A value affect the shape of the graph? Well, remember, you had, let's just go through this again. Let's try this real quick. Let's try negative 1 times, I don't know, let's go with x minus 2. And now we have a vertex here, and we have intercepts, or we have zeros at 2 and at 5, right? Where the function produces zeros at 2 and 5. So now what we need to do is we need to figure out what happens if I change this value. And I'm going to just make it really dramatic. Look what happens when I put a 0 in front. Whoa, what happened there? Got 10 times as tall, right? Let's see, went from 22.5 at 10, and now it's at 2.25. It's a tenth the size. So indeed, the height of the vertex is going to get impacted by this here. How about if I went to 0.1? What's your prediction? Well, that vertex is now at 0.225. So you can see, whatever number we put up here, if it's bigger, it's going to make it like a taller, narrower parabola, right? And if it's smaller for A, it's going to make it a shorter, squatter parabola. So here we go, negative 4 or negative 2. There you go. So you can see the impact that A has there, and you should be able to answer that. That will affect the shape of the graph. If this number is very, very, very small, like 0.002, oh my gosh, it almost doesn't look like a parabola anymore. Let me go back, 0.02. See how big and wide and curved this is, right? It's huge curve now, big and wide, almost like the shape of the Earth, the surface of the Earth or something. And then as soon as we make it a little bit smaller, or larger rather, and then make it larger yet, and you can see what's happening to the shape, so you can answer that there. Okay, it says use a graphing calculator to determine the zeros of each function. Sketch each graph. You should be able to do that. You can graph these, right? You find the zeros. You can, then it says, then write the equation of the function in factor form. Okay, let me help you with this one. Then you're going to do the next ones. Okay, so here we go. It says h of x equals x squared minus 8x plus 12. So I'm just going to put that in here. So I'm going to go, what was it? X squared minus 8x plus 12. So we're going to go like this. X squared minus 8x plus 12. Okay, so what do we know about A? A is going to have to be what? Is it going to be positive or negative? So looking at this, you should realize, oh, it's going to be a positive A, right? Because it opens up, like smile here. And then what are we going to say right here? What are these numbers here? These are zeros are 2 and 6. So what's that telling me? Well, that's probably suggesting, right, that what I need some value for A that's positive, and then my parentheses are going to have to be x minus 2, wasn't it x minus 2, right, inside of my parentheses, and then what am I going to have? I'm going to have, well, this is going to be x minus 6, right? We said x minus 6. But the only question is, what am I going to use for A? What am I going to use for A? How am I going to find A? All right, so good question. So how are we going to figure that out? Well, what we're going to do is we're going to factor this out. We're going to see what happens if we ignore this for a minute, A, for a minute. Don't even worry about it. And just multiply these two out. We're going to FOIL them out or multiply them out. We're going to expand them out, and we're going to see what happens. Okay, when I multiply x minus 2 times x minus 6, and see how close that gets me here. So let's do that. Here's a rectangle, right, just to help me out to think through multiplying this, right? So I would say I have x right here minus 2, and I'm thinking of my area model here, right? So length times width. So I'm going to draw like that, and I'm going to say this is x, and this is minus 6. We're just going to think of it as a length of minus 6. I know that doesn't work, but we're just going to think of it that way. So what do you have in this area? And here would be x times x, which is x squared, right? And we have x times negative 2, so that is negative 2 times x, negative 2x, right? Then over here we have negative 6 times x, so that's negative 6x. And then over here we have negative 6 times negative 2, which is positive 12. Positive 12. So let's write that whole thing out. We end up with x squared. And then we end up with negative 2 and, so these two can be combined. They're like terms. Negative 2 and negative 6 makes a total of negative 8x, right? Negative 2x and negative 6x is negative 8x. And then over here we have plus 12. So think about this now. Here we go. I've got this. What I want is that. How do I need to change this to make it look like that? The answer is I don't. I don't need to change this. This is perfect just the way it is. And so if I don't want to change this, what should I put for A? So some people would say, oh, what you put for A is you put a 0 here so it doesn't change anything. But you're wrong. If I multiply by 0, everything is going to turn into 0. That would change it completely, right? So the only number we can multiply by would be 1. So it would have to be a 1, x minus 2, and then x minus 6, right? X minus 6. So that would leave everything just the way it's supposed to be. And then, of course, we don't really have to write the 1, okay? So that is how we would do that problem there. Okay, the zeros would be at 2 and 6, so we can write the factored form. You can draw it out. Here we're going to get one that's a little bit different, okay? I want you to take a look here and see that it's a little bit different, okay? So I can see some things here that should be cluing us in already, but negative 2x squared plus 6x plus 20. So here we go. negative 2x squared plus 6x plus 20. Is that right? Hold on. Negative 2x squared plus 6x plus 20. Okay, good. So, what do we need to do to figure this out? Well, we can see our zeros again. Here's our 0 right here. This 0 looks to be at, wait a minute, that's negative 5, so it's negative 1, negative 2. So we have a 0 at negative 2, and our other 0 is over here at 5, positive 5. So that tells me if I put it in factor form, I would have x plus 2, right? X plus 2. All right, and then we'd have that 5 over there telling me x minus 5, right? So this is kind of factored, and it looks a lot like, I mean, I know if I put that in, I'm going to get zeros here and here. But it doesn't yet look like this, so let's do our multiplying and see what happens if we multiply those out, and then maybe it will tell us what we need a to be. So here we go. I'm going to pull this down like this, ta-ta-da, and across. I'm going to call this x, and this is plus 2, right? Positive 2. And then over here I'm going to go x, and this is going to be minus 5, right? X minus 5. Okay, we multiply out. I get x squared. Over here I get 2x. All right. Over here I get negative 5 times that's negative 5x. And then over here I get negative 10. Negative 10. Okay. Putting this all together, I end up with x squared. And negative 5 plus 2 is negative 3x. Ooh, that's an ugly 3, but that is a 3. And then over here we have minus 10. All right, so is this what we were looking for? And the answer is no. This is not what we wanted. So I think, what do I need to multiply x squared by to make it negative 2x squared? The answer is negative 2, right? And that's the part that's missing here, is the negative 2. Well, this makes multiply, I can figure out the a. What if I put negative 2 there? What would happen to the rest of this? If I multiply this by negative 2, I get negative 2x squared, right? So this would become negative 2x squared, right? What does this become? Negative 2 times negative 3. Well, that's positive 6, right? So we get positive 6x. And what is negative 2 times negative 10? Well, that's positive 20. So we can see all that's missing here from this, that should be a 2. Okay, so now we have exactly what we were looking for, and we found out that the missing factor was negative 2. And why is that missing? Well, because there's a negative 2 here, there's a negative 2 in here, there's a negative 2 in here. If you factored out the negative 2, you'd get this, and then this is easily factored here using our area model. In the end, we can see where our zeros are, and then we can use that to help us write it. So there's your answer to the next one. And, oh, I better take the writing away. Let me go back here. I want you to work on these. These are just practicing these out, and I'm going to have you do it. All right? Here it says, just looking at it, find the zeros, right? And actually, I'm gonna actually show you something, because this is pretty cool, okay? And this is what we talked about. All right, let's see. Why don't I just take one of these? Why don't I take this one first, and then I'll do that one? But let's look what happens, okay, over here with this. So we're talking about finding zeros, and the term zeros we know also means the x-intercept. And really, when we talk about a zero, what we mean is that the function equals 0. So when v of x, we're trying to find out for what value will v of x be equal to 0. Well, when will it be equal to 0? So what we do is we know, oh, well, we're trying to find out when will this equal 0. So you can do this like this. You just put a 0 in instead of v of x, right? So 0 over here is equal to x times 2x plus 6. So now there's only two things that can turn this multiplication into 0, right? You have two factors. Let's talk about multiplication. In multiplication, which I'm multiplying here and here, these two things are factors. That's why we call it factored form, right? So this is being multiplied by that. Both the factors are multiplying each other, and somehow it's turning into 0. So how could that be? Okay, the only way this could be is if one of these factors is equal to 0, right? So what we're going to do is we're going to, we'll set each one of these as equal to 0. So we could say, all right, let's try what would happen if this was equal to 0. Well, then we would say, aha, x is equal to 0. That would be one value for x, right? If I put 0 in here, that would make the function turn into 0, right? The other one is, what would I need to put in here to make this part turn into 0? So I would say, okay, let's put a 0 here. And I go 2x plus 6, right? 2x plus 6. And I'm asking the question, oh boy, not doing that very well. My computer is not keeping up real well. Here we go. I'm asking the question, what do I need to put in here to make this turn into 0? So how do we solve this? Well, we take away 6 from both sides. Take away 6, right? And we get, we get an ugly mess of what we get. If we do that, we're going to get 2x over here. 2x over here is equal to 0 minus 6 is negative 6. Negative 6. Now I'm going to divide by 2. Man, that is ugly stuff. So we're dividing by 2. These guys will cancel. I divide this one by 2. And my writing is atrocious, but hang with me, okay? And x is be equal to negative 6 divided by 2 is negative 3. So what is this telling me? This is telling me that, this is telling me that when x is equal to negative 3, if I put that in there, negative 3, then this would be negative 3 times 2 is negative 6. Negative 6 plus 6, this would turn into 0. Doesn't matter that this is negative 3 also, because 0 times negative 3 will make the whole thing 0. So my zeros are whenever x is equal to negative 3, and also whenever x is equal to 0. And to prove it, let's try graphing. Oh, this isn't going to work. Here we go. So this was x times 2x plus 6. So here we go. X times 2x plus 6. And there we have it. We have a 0 at 0, and we have a 0 at negative 3. So, all right, the reason I said let's do that is because I really wanted to show you, here we have this in factored form, right? And we said, oh, looking at this, I know my zeros have to be at 2 and at positive 2 and at positive 7. And I've been telling you, we're going to talk about why is that the case. Well, let's think about this. If this factor is 0, then the whole thing will turn into 0, right? So that means I can just say, okay, x minus 2 equals, x minus 2 equals, computer moving slow, equals 0, right? So I'm asking myself the question, what would x have to be equal to in order for this to be equal to 0? And you see that minus 2? So the way we solve for x is we add 2. So plus 2 over here, and we add 2 there. Plus 2 over there. And then what do we end up with? Well, these cancel out, so we just have x. We say x is equal to 2. So clearly, if I put a 2 here, that's going to make this 2 minus 2. It's going to turn into 0. And the same logic holds. If I put a 7 here, then that minus 7 is going to make it a 0. Same thing is true over here. If I put x plus 1 equals 0, well, then what would this have to be? It'd have to be negative 1. So negative 1 plus 1 is 0. That's why the opposite sign and the same number is going to turn this into 0, right? The opposite sign and the same number. Here we have this. What would this have to be in order to be 0? 5 minus what equals 0? Okay, ask yourself that question. 5 minus what equals 0? Do you know what you would have to take away from 5 to get to 0? I hope you do. Okay, so that's how you can do these, is that you basically just go through and you are making sure that you figured out every single time what turns these factors into 0. Once you do, you know the zeros, okay? And that will wrap up what I want you to work on today. I'm going to make a second video in case you finish early.